Hello students, I am Dr. Mrs. Kanitkar with Mrs. Shreya Vatve from Modern College of Engineering. We are going to learn today stick diagram from the course VLSI Design and Technology. Reflection spots are on the slide number 5, 8 and 10. What is stick diagram? Stick diagram are these are the simplified graphical representation of the layout without the need for scale accuracy. Here are some points that summarize the key aspects. First one, graphical representation. Stick diagrams are a simplified graphical view or cartoon of a chip layout. They are not drawn to the scale, which makes them easy to sketch. Simplified components. In stick diagrams, transistors are represented as zero width line and have no area. This simplification contrasts with the actual layout where transistors have specific size and placements. Limitations. Stick diagrams do not have exact placements of components like transistors, wire lengths, wire width, or tub boundaries. This lack of detail is intentional to maintain simplicity. Purpose. Despite their simplicity, stick diagrams serve as useful tool for conceptual layout design. They provide guidance for initial layout planning, allowing designers to visualize the arrangement of components and connections. Practical use. Designers often use stick diagrams to explore different layout possibilities, adjust transistor placements, reroute wires, and optimize layout efficiency. They can be drawn using basic tools like colored pencils or dry erase markers, making them flexible for iterative design process. Overall, stick diagrams play a crucial role in the initial stages of chip design by offering a quick and intuitive way to explore layout ideas and make preliminary design decisions. In stick diagrams, different components and materials are often represented by specific colors to make the diagram easier to interpret. For example, red color is used to represent polysilicon. Polysilicon is a material used in semiconductor manufacturing processes, particularly for gate electrode in MOS transistors. Green color, which represents N diffusion. N diffusion refers to region where dopants have been diffused into silicon substrate to create regions which an excess of electrons. Yellow color represents P diffusion. P diffusion refers to region where dopants have been diffused into a silicon substrate to create regions with a deficiency of electrons. Blue color represents metal. Metal layers are used in ICs for interconnecting various components and layers. They typically form the conductive paths between different parts of the circuit. These colors help engineers and technicians quickly to identify different parts of the circuit or device when analyzing or troubleshooting. By following this color convention, they can easily understand how different materials and components are interconnected within the semiconductor device or integrated circuits. Stick diagrams are a higher level abstraction used in semiconductor layout design. They focus on representing the topological relationship between components without detailing exact dimensions or low level physical characteristics. So, stick diagrams typically do not include exact placement of components. Stick diagrams show relative positions and connections between components but do not specify their exact coordinates on the layout. Transistor sizes, they do not indicate the dimensions like width or length of the transistors or other components. Wire lengths and widths. Stick diagrams do not specify the exact lengths and widths of wires used for connections. Tub boundaries. They do not depict the exact boundaries of transistor regions, such as diffusion or wells. Parasitic elements. Stick diagrams do not include parasitic elements like capacitances and resistances that naturally occur due to the physical layout. Stick diagrams are more concerned with the logical and topological layout of components and connections within a chip design. They provide a simplified view that helps designer quickly visualize and understand the layout structure without getting into the complexities of physical dimensions and parasitic effects. Stick diagram notations. So here are the colors with which these stick diagrams are drawn. As mentioned earlier, blue color is represented with metal. For metal, polysilicon is represented by red color, N diffusion is represented by green color, and P diffusion is represented by yellow color. If colors are not drawn, then there are different ways of or shades of drawing the line style which will indicate the same, that is with dotted line metal, the straight line polysilicon, dash line is N diffusion, and dash line with more width is represented P diffusion. This is a buried contact and this is a contact cut. Now the reflection spot 1. Define stick diagram in one or two sentences. Rules to draw stick diagram. First rule, when two or more sticks of the same type cross or touch each other, that represents the electrical contact. When two or more sticks of different type cross or touch each other, there is no electrical contact as shown here. Red line and the blue line, they are crossing, but there is no electrical contact unless and until you show the contact here. When poly crosses diffusion, it represents the transistor. Here is NMOS transistor. This is source, gate and drain. And here is PMOS transistor, which is again source, gate and drain. If contact is shown, then it is not a transistor. Now reflection spot 2. Which color is used for polysilicon? The next rule, in CMOS, a demarcation line is drawn to avoid touching of P diffusion with N diffusion. All PMOS must lie on one side of the line and all NMOS will have to be on the other side. So here this is a demarcation line which is separated by NMOS and PMOS. So the stick diagram for CMOS inverter, which has PMOS and NMOS transistors which are connected. So here the contact, the metal contact is shown. Then this is PMOS and NMOS, P diffusion, N diffusion. Then the transistors which are drawn with a polysilicon. The contacts are drawn, these are connected with a contact. Here the gate, which this polysilicon with red, it is shown here, it is connected with NMOS and PMOS. then this drain is connected together to get the output, and it is separated by demarcation line. So this is a stick diagram for CMOS inverter. Now the reflection spot 3, which line separates NMOS and PMOS transistors. This is a stick diagram for NAND gate. So here there are two PMOS transistors which are shown here with a yellow stick, and the contacts, metal contacts, are shown with a blue line. This is polysilicon which are connected with the transistor, and here with this green it is NMOS which is connected. They are connected with the metal. This are the blue metals. So this is the stick diagram for NAND gate. Thank you.